Welcome to qnawire.
Consider an electron, and we are looking at that electron in its rest frame. Then, the momentum of that electron in its rest frame is equals to 0. The energy of that electron in its rest frame is its rest energy. So, it is equals to its mass times c squared. Now suppose that a photon is emitted. So now we have an electron, say we have a photon, and we have the following situation. So now the momentum of the electron is something else, say Pe prime. The energy of that electron is also something else, E prime. And here we have the momentum of the photon and the energy of the photon. By using conservation of momentum, it must be true that Pe is equals to P prime plus Pp prime. So the momentum before the emission should be equal to the momentum after the emission. This implies that 0 is equals to Pe prime plus P prime. And therefore, we conclude that the relation between the momentum after the emission is equals to the following: Pe prime is equals to minus P prime. Now, by using conservation of energy, it must also be true that mc squared is equals to the square root of P prime c squared, P prime squared, plus m squared c to the fourth, plus h times f. This is the energy before the emission, this is the energy of the electron after the emission, and this is the energy of the photon. Now remember that the momentum of the photon is equals to the energy of the photon divided by the speed of light. Therefore, we can say that Pe prime is equals to minus hf divided by c. And now we use this result here to get mc squared minus hf, send this term to the other side, is equals to the square root of h squared f squared divided by c squared times c squared plus m squared c to the fourth. We can simplify c squared with c squared to get mc squared minus h times f is equals to the square root of hf squared plus mc squared under a square root. Now we can elevate both sides to a power of 2 to get mc squared minus hf squared is equals to hf squared plus mc squared squared. Now, expanding the left hand side, we get mc squared squared plus hf squared minus 2 times mc squared hf is equals to hf squared plus mc squared squared. This term cancels this term cancels this term, and we are left with 2 times m times c squared times h times f equals to 0. M is the mass of the electron, it's non-zero. C is the speed of light, it's non-zero. H is Planck's constant, so it's also non-zero. 2 is obviously non-zero, so the only possibility to solve this equation is f equals 0. And f equals 0 means that our photon has 0 energy, and therefore we actually have no photon. Then, with this, we can see that the only possibility is that the electron emits a photon with 0 energy, which is the same as saying that it doesn't emit a photon at all. So, it's not possible for it to emit a photon and also obey the rules of conservation of momentum and energy.